Topic 3 is going to focus on density and temperature. Density is a ratio of the amount of matter, typically your mass, present in a given volume of that substance. Depending on the substance that you're working with, sometimes you can determine the volume based on its dimensions, such as if it's cubic or rectangular, using length times width times height. Or sometimes you have to find it indirectly, such as through displacement with a graduated cylinder, something that is not able to dissolve in what is already in the cylinder, won't float in what's in the cylinder, but will not react with what's in the cylinder. It is a physical property. It can change, and it often does change dependent on its temperature. If it is something with a greater density, it's going to sink in something with a lighter density, a smaller density. And so there's your equation for density. You've probably seen this before as well. If you prefer this for algebra, you might want to write this down. DC, Maryland, Virginia, Department of Motor Vehicles, hide the one that you're looking for, and that shows you the relationship between the other two. So when you hide D, you see M is over V. When you hide V, you see M is over D. And when you hide M, you see that D and V are in the same row together, so they're being multiplied. So here we have iron with a density of 7.87 grams per centimeters cubed. We're told the iron's volume is 75 milliliters. What is its mass in grams? So we're trying to find M, which would be density times volume. You have a density and you have a volume, but you will notice that the density's volume is not the same as the actual volume of your iron sample. I want you to think back to what we talked about with dimensional analysis and the relationship between milliliters and centimeters cubed, that's a 1-to-1 ratio. So because of that, we don't have to do any fancy dimensional analysis. Those units are equivalent and they can cancel out. And so when we are solving this problem through, because it is a calculation, we want to look at what type of calculation it is to determine its sig figs. Multiplication means we want to look at all the sig figs in our measurements and go with the one with the fewest. The density had 3 sig figs. The volume had 3 sig figs because of the trailing 0 with the decimal. So we want 3 sig figs in our answer. So when you multiply these together on your calculator, you're going to get 590.25. With 3 sig figs, we're going to keep the 590. The 2 would not round the 0 up, but to make the 0 be a significant digit, we need to make sure we include that decimal point, or we write it in notation form as 5.90 times 10 to the second. Our second example is going to involve a volume that is not able to be measured directly. We have iron pellets. We're given the density of those iron pellets, and we are pouring them into a graduated cylinder that has a certain volume of water already, 12.7 mils. And when the iron pellets are added to the graduated cylinder, the volume rises to 21.6 mils. And we want to know what the mass of this metal is. So just like before, find mass, we would need to multiply density times volume, but we need the density of the iron as well as the volume of the iron. We know what the volume of water was before we added the iron to the graduated cylinder, and we know what the volume of the water is after we added the iron to the graduated cylinder. So to get just the volume of the iron, similar to what you've done in lab before when you weigh an object on a balance in a container and you weigh the container by itself, we're going to need to subtract these two measurements to get the volume of just the iron. Because we're subtracting, we're looking at decimal places. Both of our measurements had 1 decimal place, so we want to report our subtracted answer to 1 decimal place, 8.9. Now that we have our volume and we already had our density, we can use those two to get our mass. Same as before with the previous example with milliliters and centimeters cubed. They're equivalent, they cancel out. We're multiplying, so now we look at sig figs, and we see that the density has 3 sig figs, but the volume only has 2. So when we multiply these two values together, your calculator is going to give you an answer of 70.043. We want 2 sig figs, so we're going to keep the 70, and to make that 0 be significant, sorry, the 0.0 is not going to round it up, so we want to make that first 0 be significant by putting a decimal immediately after it to show that this value consists of 2 sig figs. And then grams is going to be the unit it's reported in, since the volume units have canceled out. The second part of this video is going to focus on temperature, just reviewing with you how to go between Celsius and Kelvin. Although we live in a very English society, using units such as Fahrenheit and inches and yards and miles, calories. We are only going to be dealing with temperatures in Celsius and in Kelvin in this class. So temperature is looking at the random motions of your molecules. We're doing a lot with temperature this year. You're going to be checked for your temperature every day when you walk in. I'll be checking mine before I walk into school. We can measure it with thermometers, or as we're seeing now, you can measure them with digital thermometers. And in lab, we measure them often with temperature sensors. You can't measure the energy of a substance directly. You can, however, calculate energy transfers based on temperature changes as well as phase changes. And we'll spend more time on that later on this year. But the relationship between Celsius and Kelvin is truly a mathematical relationship. Lord Kelvin came up with it, trying to come up with a way to determine characteristics of substances that would not end up with negative values because of the negative portion of the Celsius scale. So he took the absolute zero, negative 273.15, and set that as a 0 point, and basically just added that value to any Celsius temperature so that the lowest possible Kelvin temperature would be 0 Kelvin. There is no degree sign because it is truly not measured. So quick and simple. If the average temperature in school is 25 degrees Celsius, what would this temperature be in Kelvin? We would add 273 to go from Celsius to Kelvin. 25.0 has 1 decimal place. You probably have seen this reported as 273 before. You keep the number of decimal places that are present in your temperature. So 25.0 would have 1 decimal place. If you just use 273, your answer would have been 298.0. But I don't want you to round your temperature decimal places down. You are dealing with addition. That 273 or 273.15 is a constant. So the number of decimal places that you report in your temperature answers would be the same as the number that you had in your starting temperature.